So, okay. So, I think, yeah, it is recording now. Yeah. So today, actually, I have one request prior to the session, to explain about the countability of the rational numbers. So I'm gonna explain it after I explain about the limits. So today, starting thing to start with the limit definition, because most of you guys in the previous week has sent some question regarding limits and see how to prove it. And I saw some people have some confusion to choose how to choose the delta and how to prove that one. And then I think it is good to show you how you can solve the problems using the limit definition, specifically how to handle that inequalities to get that sorted, like when you're solving the limit problems. And then after that one, I'm gonna solve a couple of problems out there to give you some experience. And then I'm gonna do that the countability of rational set. So in the meantime, if you have any problem to be discussed, especially with the limits or any kind of thing, you can just put it in the WhatsApp group or to the Zoom chat if as a picture, so then I can discuss that one. So first of all, I will just write the limit definition, the basic that you need to remember. So we tell like we sell for sake of easiness, I take this L is a real number to be start with, and then this if we can say limit x goes to a, and also to be the thing simple, I take both L and A to be real numbers. So if we say limit x goes to a, fx equals L, this double implies that, or this definition is, for any given real number epsilon, we can find a delta which is also a positive number such that this thing implies this. So this is the basic limit definition we know. So in other words, if you need to prove, if you give a question to prove limit is this, you have to prove that this definition holds, right? In here, the most important thing is you have to think, it's basically what you are saying is, in other words, if you need to prove this one, let's say if you are given something like, let's take a very basic example, limit x goes to 1, x plus 1, we know it is 2. If you need to prove that one, you need to prove for all epsilon greater than 0, you need to find some positive constant delta such that 0, x minus 1 less than delta, this should be implied x plus 1 minus 1, so minus 2 less than epsilon. Basically, when you're trying to solve it, you have to find a delta for work with any given epsilon. In other words, you have to focus on this part. Specifically, you have to show that you can find some positive number to replace delta, and it should imply that for any given positive constant epsilon, this term is less than epsilon. So this is the basic scenario. Is it clear? Or it is not? If there's any confusion there, just let me know. So how to do that one? I think most of the time people are confusing with how to find the delta. You need to remember that whatever you do using this limit definition, when you're going to prove that one, you have to start with this inequality, not with this. Of course, we need to prove this part holds, but we have to start with this. Is it clear, or is anything to be clarified up to that point? Before going to show it that one, how are you going to do that one? If you have any question, just I leave the chat open. You can just put it to the chat. Okay. Now, I think it is always good to explain with the example without going to the symbols. Otherwise, you don't understand what is the delta and kind of thing. Let's see. Let's solve a simple problem. Let's solve this one. And I explain it two ways. First, I explain how we can do that one. And then I will explain how we are going to need to write an answer to that one. if it is come to exam. If it is an MCQ exam, that's fine. But in any case, if you need to write an answer, maybe in the later semesters, you need to know this. Okay. So first, your problem is this one. Limit x goes to 1, x plus 1 equals 2. It's a very basic problem that you can do. So then we need to prove for all epsilon greater than 0, there exists a delta greater than 0 such that 0 greater than x minus 1 less than delta. This should imply x plus 1 minus 2 less than epsilon. So first, we consider this part because we need to find some delta to replace this guy, which when this inequality hold, it should imply that this inequality also be true for any epsilon. In other words, I write in the same color, we have to find some x minus 1. We have to find some positive value to put into this circle. When we put into that one, when that inequality true, it should imply that x plus 2 minus x plus 1 minus 2 is x minus 1 is less than epsilon. In this very simple example, you can see this part and this part are equal. So what is our positive number? Because we know we take epsilon to be positive. So if I put epsilon here, this will work. So for any given epsilon, our delta is nothing but epsilon itself. In other words, 0 minus x minus 1 epsilon, this straight away implies x minus 1 less than epsilon. So if you give any epsilon, it can be 1 million or 0.1 or 0.001. Let's say it should be 0.1, 0.001 or 0.10001. Doesn't matter. Whatever the epsilon I give to you, your delta is epsilon itself for this particular problem. So then you can say, when you're writing the answer, you can say, this you should write as answer, let epsilon greater than 0. So 0, x minus 1 less than delta, epsilon equal your x plus 1 minus 2 less than epsilon. For all epsilon greater than 0, there is a delta greater than 0 such that 0 minus x minus 1 less than delta. This implies x plus 1 minus 2 minus epsilon. You have to remember that in this definition we say for any given epsilon, there is a delta. This delta, some might argue that okay, it is delta equals epsilon for this specific scenario. There can be another delta. Of course, we can have another delta, but for this question, it is enough to show at least one delta exists because that's enough to prove this definition. Okay, you got everything up to now, or do I need to explain this again? Hello, before going to some, I would say, some tricky question. Anything? Yeah, a bit pick up. Okay. So I'll start with this. So my simple question is, I need to prove limit x goes to 1, x plus 1 equal to 2. So in other words, I need to prove this definition exists, right? Because in here, my A is 1, L is 2. So this is the basic definition that you get from your lecture notes, or even if you browse the internet, that is that thing that you get. And if you put A equal 1 and L equals 2 in that definition, you get this. So you have to prove that this definition exists. In other words, you have to prove that you can find a positive number to replace here or put here when 0 greater than x minus 1 less than the positive number that you are chosen, or you can choose a positive number in a way that it will satisfy this inequality, and that satisfaction of this inequality also should imply your this x plus 1 minus 2, or it simply this becomes x minus 1 less than epsilon. It means in this question, because it is a very simple question, because these two becomes equal. So you have nothing to do. You can just, for any given epsilon, if you need to put something here to get this implication correct, what you have to do is your delta in here, simply your delta becomes your epsilon. They both are equal. If you put the same epsilon here, then this implication or this implication statement automatically holds. So you have nothing to worry about that. And you can say for any given epsilon, if you choose your delta to be that epsilon itself, this definition holds. That's what you have to do. Is it clear? Or do I need to explain it again? Because this is really important, because I haven't touched, because I don't touch today the one-sided limits or anything, because I need to tell, to explain to you how to solve this problem using this definition, because once you get this correct, you can literally do any problem. It doesn't matter the infinity as a limit or kind of, because there are, I think, you can write this limit definition in 9 or 10 different ways. It doesn't matter how you write it, but if you get this correct, I think then you can write it up to any question. Okay. Okay, so these two, so I think it is creates some bit of confusion to here. So, and then when you're writing the answer, you can write simple is this way. You can write, if you take 0 and your delta to be epsilon, then this is my delta basically. Delta to be epsilon, and if you take delta to be epsilon, this statement automatically implies this one. Because if I made a simple explanation, you have to find some delta to imply this, right? You have to find some delta for any given epsilon to, when you put that delta to here, it should imply this inequality is true. So in this simple example, if you solve that term, because this simply become x minus 1, because you guys asked to explain it again, and the delta you need to choose in this particular example is nothing but epsilon itself. That's why I think. Okay, now you get an idea. Okay, then let's see some sort of I would say some sort of complex example than that one. And I would say limit, let's say x goes to 1, because it is easy for the solving, because then the solving can much more easier, because I just need to convey the idea. I would say x squared plus 1, and this is also 2. So if I need to prove this one, my definition would be, or I need to prove, or we need to prove, for all epsilon greater than 0, there is a delta greater than 0 such that 0 greater than x minus 1 greater than delta, which implies x squared plus 1 minus 2 less than epsilon. In other words, because in here also these are just rough work, right? These are rough works, and also I just do some rough works there. So I really had to find some delta where I write in white color x squared minus 1 less than epsilon. I just solve this one, right? I just simplify this one. And basically, I need to find some value for delta where when this inequality hold, that should straight away imply this inequality hold. So we need to find a delta in a way that if I put my delta there, this implies, it should imply this inequality. Or in other words, if I put some delta value here, if that when the value x satisfies this inequality, it should satisfy this inequality too. There's no way that we need to find such a way of delta. If we can find a delta for any given epsilon, then the limit is this. That is the meaning of this definition. Okay, so I just factorize this thing. So we can factorize like this one, x minus 1 times x plus 1. It doesn't matter, less than epsilon, because these are both same. Now this is a bit complex. Why? We have x minus 1 here, and we have x minus 1 here. But we cannot do much about this x plus 1 thing. In these type of cases, it means every time delta less than or minus, someone asks for every time is delta less than or minus epsilon. This is wrong. The only condition is if you put any positive constant here, it should imply this guy. So because in last case, these two both are equal, now it is not, because that is the most general case, because you cannot expect to that how this expect this in here too. Otherwise, you cannot. There's nothing to solve or nothing to work out, right? Here, you see this part here, so it is not a big problem. So you can just put any number there. If you put any number there, so you can straight away get an equality for this one. But for this one, you cannot. In such cases, remember, you can always start with this one, right? You have to put something into here. But the problem is, if you put 1 here, then you can get some inequality and prove that one. But the problem is here, you have x plus 1. So what I'm going to do is, instead of writing this one as my rough work, I write this one, x plus 1, minus 1, and minus 1. Less than, I would say, then I will write in this way. So I would say x minus 1. This is the inequality I have here, the value I have here. So I have to start with this one, get inequality with this one, and I get some sort of inequality toward this one, because I need to start some delta value here. I need to show this value exists. So what you have to do is, whenever you solve in the limit problems, you have to start with this thing, or basically in this part, and you have to substitute some delta value and get some inequalities, and using a couple of delta values, then you can arrive at your final answer. So I will write this way is x plus 1 minus 1 minus 1. It's fine. So then I can write this one is x plus 1 minus 2. Okay. Now, remember, when you are solving these inequalities, you have to use, there's another toolbox we have. We have something called triangular inequality. It is nothing but these two equations. Another thing is this minus equal sign there, this one. So these are we called triangle inequalities. So whenever you're using these inequality equations, you can use these two to get your desired results. Then what I'm going to do is, I can write this one as x plus 1 as a single term and minus 2. And then I can write this one x minus 1, x plus 1 absolute value minus 2's absolute value is 2 is greater than or equal x plus 1 minus 2's absolute value. This is greater than or equal x minus 1's greater than x minus 1's absolute value. Then I can write x plus 1's minus 2, this one, right? X minus 1's absolute value, and I would put something like 1 here, because that's the smallest integer number that I can imagine. And whenever you write something like this, always remember to put something less than this value over here. It means like if you have something like, let's say, x plus a minus b, and this is the one that you need to get an inequality for, always remember to put some number less than b's absolute value here, because then you can get more of the inequalities. Because I will explain why. Because sometimes you have to get inequalities in both, because sometimes you have to get inequalities like x plus a modulus less than something. Sometimes you have to get equation x minus plus a's absolute value greater than something. If you put some value is less than b's absolute value here, you can handle both situations. Otherwise, you can handle only one, right? So just remember the thing. Because this triangle inequality, you can write in two ways, because either this one or you can write this way too, right? So if you need to get meaningful inequality out of all of these two scenarios, it's better to put some value less than absolute value of 2. Okay, now I can, using this equation, I can get x plus 1 absolute value is less than 3. It means if I take my delta to be 1 as some example, I can get x plus 1's absolute value is less than 3. And this implies our inequality over there, this guy, x minus 1 times x plus 1, this one is less than 3 times x minus 1, right? Because this is the one that we need to get inequality for. If we can show this is less than epsilon, then we are done. Because this is less than epsilon means automatically this is less than epsilon, then we are done. So what is my delta would be to show that one? What should I put here to imply this? So what should I put here? Anyone? Can anyone suggest a value? What is the value, the positive value I should put here to imply this? Yeah, exactly. I have to put epsilon over 3 to get this one, because once I put epsilon over 3, it straight away implies, because we can multiply both sides by 3, and then it will imply this. Okay, so this is my rough work. From here to here, it is my rough work, right? Then when we are writing my answer, we write in a very nice way, we do all the rough work. Then we can say, when you're writing the answer, we can say, you can put it, I would say, if you're writing your answer, let's say, if this is your paper, you can do rough works in a side. Or sometimes you can do a separate sheet and attach that one. But I prefer to do in it. I get some sort, let's say 3 or 4 centimeters from the right-hand side from my paper, and I do my rough works over there, right? Because then examiner see your rough work, because everyone do this rough work, right? And then ask how you this, I take this one, because I just put a number which is less than this, the absolute value of 2. And 1 is the simplest number that I can imagine. Because the thing is, I will explain why I taking this way after I solved this problem. But for now, you can just think of it, because it's the simplest possible positive number that I can imagine to solve this problem. And then this is my delta. So then I'm going to write in the answer. So what I'm going to do is, I start with let delta equals minimum of 1 comma epsilon over 3, right? Then 0 less than x minus 1 less than 1 less than or equal delta, because delta is minimum between these two, so it should be less than or equal to this one or this one. And this is implying my x squared plus 1 minus 2 is less than 3 times x minus 1, because that's what I get it from here, right? I get it from here. Then 0 less than minus 1. Oh, sorry, it should be in the other way around. Delta less than or equal 1, less than delta less than or equal, this is epsilon over 3 because I take the minimum of these two. And this should imply x squared plus 1 minus 2. Sorry, this guy. 3 times x minus 1 less than epsilon, because that's what this is straightforward, because if we just multiply by 3, we can go straight to this one. And then we can say, thus 0 x minus 1 less than delta, this is implying x squared plus 1 minus 2 less than epsilon. Thus, for all epsilon greater than 0, there is a delta greater than 0 such that 0 less than x minus 1 greater than delta, it is equal x squared plus 1 minus 2 less than epsilon, which is implies limit x goes to 1, x squared plus 1 equals 2. Is it clear, or do I need to explain it again? Hello? Is it clear? Do I need to explain it again? This is the where that you need to write your answer first. Okay, so I get some sort of message. Okay, now I will explain why I tell you. Let's say you have, is it up to now clear now? So you can just take a note down, or because anyway, I'm going to share with this notebook and the recording with you, so you can just refer it back again later. I saw the delta can't be 1 or any other value lesser than 2, right? Yeah. Technically, I will explain that later. I will explain that now. So this is the equation that you put. I think you are referring to here, right? Because someone asking why I take this value to be 1, or why it is that value 1 need be less than absolute value of 2. I explain it here. Because we have some inequality, like here, right? X plus A minus B, and we have to put something here. So let's say I put some value C here. Then I can put the triangle inequality two variations. One is x minus A absolute value minus B's absolute value is less than C. Other triangle inequality I can get is B's absolute value minus x plus A's absolute value less than C, right? Because we know that x plus A's absolute value minus B's absolute value less than x plus A minus B from the triangle inequality, and also B's absolute value minus x plus A's absolute value is less than this guy, because from the triangularity inequality. Okay. So now, substitute, get the inequalities for x plus A's absolute value for all of these two equations. So I can get from this one, x plus A's absolute value is less than C plus B's absolute value. So if I put any positive value for here, because we cannot put negative value there, because absolute value cannot be less than negative value, it is fine. This inequality is fine. But for this inequality, the second inequality, you have to get, let's say this one, you want to get B's absolute value minus C greater than x plus A's input. Because in some problems, you have to get this inequality as well. In such cases, what would happen if we pick a value, let's say C is greater than your B's absolute value, then this value becomes negative, and this inequality becomes meaningless. If you need to get a meaningful inequality to solve your problem, it's always good to pick the C less than your B's absolute value, right? Okay, that's fine. Is it clear? Okay, so someone is asking, and I put some of you guys as co-hosts, like make sure that you admit your colleagues, otherwise they will be waiting outside. Okay, so here is something like this. Let's assume, I will write it again. Let's assume you have some inequality like this, right? And you have to put some value C to make some inequality or make some result or inequality results to solve your problem, right? In this, when you're solving this, you can get two inequalities. One is like x plus a minus b. Using triangle inequality, you can get this one, and also you can get b minus x plus a minus c. And then for this term, the part including x, you can result two inequalities. From this, you can result x plus a minus c plus b. And here you can result b minus c greater than, this is x plus a is absolute value greater than absolute value of b minus c. So what would happen if you pick c greater than the absolute value of b, this value become negative. And then the second form of inequality becomes meaningless. Because absolute value is greater than minus value is, it is a meaningless inequality. So if you need to get some equation to this guy less than some positive constant, we definitely have to put this c a value less than b's absolute value. So to be on the safe side, because you don't know what is the inequality that you need, so then it is better always as a practice, whenever you have this kind of equation, choose this c a value which is less than the absolute value of b. That's what I explained as a practice, right? Is it clear? Because then you can get the both two equations are meaningful equations, and then you can choose the equation that you need. Okay. And also someone is asking about, can you explain this part? I think the one you send me the direct message, can you send, are you asking about this one, or ask you about this one, the red color one, or you asking about this one? Can just you quickly send a chat message? You can set either set red or black. It is a one line of text. The first one. Okay. So here. Okay. So here what I do, because the problem is, I go back to here to explain. It is a question is why you take this inequality to get this one. Okay. So here, as you can see, in this side, you have two terms, right? So you have to find some delta to imply this whole bunch is less than epsilon. But you cannot do it at once. So what I do, to make this thing simplify, I take, okay, let delta to be 1 or some chosen value, right? Because what I try to do is I try to eliminate this guy from the equation. So if this delta is 1, then I can get some inequality and tell that x plus 1 is less than some known positive constant, and which is eventually become 3, and then I can easily pick some delta value to make that whole bunch of value, let's say m times x minus 1 value to be less than epsilon. It is very easy to choose a delta value to go in that way, rather than having this x here, because this is the part which make this complex than this question we see here. Because here, if you take here, we can get x minus 1 here, and it's only x minus 1 here. Simply, your delta becomes epsilon. But here, you have this extra term. To get rid of that one, what we're going to do is we take some delta and make some inequality for that one. And then to handle that one, we use this trick. We get minimum of these two. So when we take the minimum of these two, so when we take the result we take for the epsilon for a fixed value is also there, and also the delta with our epsilon or our final epsilon, the delta value, which we make to get this inequality, is also true. These both are true. Because we cannot get this result with a single epsilon value as in the previous case. To handle such situations, what we do, we choose some predefined epsilon value, delta value, and make that to get some another equations or another inequalities, and then using those inequalities, we will simplify our expression here, and then we do make the substitution and prove that this part is less than epsilon. Is it clear? Or do I need to explain it again? Hello? Hello? Okay, I can do another example. Okay, so let's do another example. I try to go slow as possible. Okay, so I would say limit, let's say x equal to x squared plus 3x plus 1. So the limit would be 4 plus 6, 10, and 10 plus 1 means 11, right? So we have to prove this one. And basically this means that we have to prove for all epsilon greater than 0, the x delta greater than 0, such that 0 less than x minus 2 less than delta. This should imply that x squared plus 3x plus 1 minus 11 less than epsilon. As previously my rough work, I write in red. So I can take this part and this part. So I have to prove I can find some delta which implies this one, x squared plus 3x minus 10 less than epsilon. So I can factor out these two. So it is basically x, and I think it is minus 5 and plus 2 less than epsilon. No, it is in the other way around. It's in the other way around. Okay, it is plus 5 and minus 2. Okay, so this is. So then here also you have this part here. So it is not a big problem, because let's say imagine this is a constant. Let's say this is some constant called m. So then we have m times x minus 2 less than epsilon. So if we put our delta to be epsilon over m and put it there, and problem be done. But the problem is this is a variable with respect to x. So then we need to get some inequality to this one and get rid of that one. But the problem is, whatever the inequality that we need to get for this one, we have to start from inequality from here, right? That's the biggest problem. So once again, we write x minus 2's absolute value, it is equal x plus 5 minus 5 minus 2, right? We can write this as x plus 5 minus 7. Once again, because 7's absolute value is 7, so we can put some positive value less than 7. I would say 1 because it's the simplest positive number that I can imagine like that one. So I can take x minus 2 less than 1. This is implies x, we will say let, right? Let this one. And then we know x, x plus 5 absolute value minus 7 less than x plus y minus 7. This is absolute value. This is equal x minus 2's absolute value. And therefore, we can take x plus 5 minus 7 less than 1. And then we can say x plus 5 absolute value less than 8. Thus, we can say 0 less than x minus 1, x minus 2 less than 1. This is implies our this guy, right? This guy, x plus 5's absolute value times x minus 2's absolute value less than 8 times x minus 2's absolute value, right? So then, if we take our delta to be let 0 to be x minus 2 to be, let's say, epsilon over 8, then 8 times x minus 2 less than epsilon. So this is my second delta that I need to choose, because if I have this one, if I get my delta to be epsilon over 8, it's game over, right? So first, I get an inequality using a constant value, and then I get some inequality for this x plus 5's that's absolute value, which is this guy. And then the second case, because I only have x minus 2's absolute value there, I can straight away pick a delta to satisfy this inequality because it is just a constant. But if it is not a constant, I cannot do that one. Okay. Then I can write my answer, my final answer. I can say let delta equals minimum 1 epsilon over 8 and epsilon greater than 0. Right? So then I can say 0 less than x minus 2 less than delta, which is less than or equal to 1. This is implies from here. I know it's a bit confusing, but 3x minus, I would say, plus 1 minus 11. This is less than 8 times x minus 2. And 0 less than x minus 2 less than delta less than or equal epsilon over 8. This is imply 8 times x minus 2 less than epsilon. It's straightforward. And then you can tell, thus, for all epsilon greater than 0, there is a delta greater than 0 such that 0 greater than x minus 2 greater than less delta, which is equal to, which is implies x squared plus 3x plus 1 minus 11 is less than epsilon. And then you can say this is implies limit x goes to 2 x squared plus 3x plus 1 implies 11. So this is how you're going to choose that one. So basically, no matter where you do, first, you have to simplify this one and see what are their factors. And then you have to eliminate the factors other than this one using some constant delta values. And then let's say you use 3 delta values. Let's say delta 1, delta 2, delta 3, and so forth to get some expression less than epsilon in this way. Then you have to, in final step, what you have to do in your right answer, writing the answer, let delta to be minimum of delta 1, delta 2, delta 3, and then you can write all of your result and get to an implication. Oh yeah, we need to assume that epsilon naught is in the beginning of the proof when we set the interval for delta. No, you don't have to assume that one. That's not. Because delta, the other important thing is, whenever you're proving, you are free to choose this delta. You can put any positive value for delta. The only constant is it need to be a positive one. You can put any positive value to satisfy, and if that positive value can satisfy this equation, and that is the delta that you are looking for. Delta has no restrictions as long as it can satisfy this condition, right? Let's say if delta can be 100 or million or 0.1, doesn't matter. We can pick any positive delta. You have the freedom to choose the delta, but the problem is you have to pick the right delta to satisfy this equation. Is there any question regarding this one? Any question that you can ask? Or if anything that you need to clarify how to solve this one, it is okay to consider delta to implies inequality in inequalities. Is it okay to consider delta to implies to inequalities sometimes? More than one. Yes. Sometimes in some I would say, very complex situations, sometimes you have to pick one, and then you have to pick another equation. Let's assume this one. Let's say, I would say something like this one. Let's say limit, let's say x goes to 1, and then we have something like x squared plus, yeah. So let's say something like this one. I'm not going to solve this problem, and I'm going to show you. Let's say you have something like, you have to solve something like this one. X minus 1 less than delta. You have to find some delta like something, and this side is something like x plus 2, x plus 3, and x minus 1 less than delta. Then x plus 2, what we have to do is we have to get x plus 2 minus 1, and x plus 3 we have to get minus 1. And then this is become x plus 2 minus 4, and this is become x plus 2 minus, sorry, this minus 3, minus 4. Okay, so in some cases, sometimes you can put all the, let's say you put 1 for this and 2 for this, and then you have 2 delta values, right? To get this equation to be done, right? Because this is actually, then you put, let's say 0 equals x minus 2, so x minus 1 less than 1, and it is equal something, and you put, let's say, let's do, I just work out here, so then you will explain, otherwise you will confused. Okay, so let's get inequality for this one first, right? I can get, let's say, x minus 1 equals x plus 2 minus 3. And then I would say, if this is, let's say, 0, x minus 1 less than 1, this is implies x plus 2 minus 3 less than x minus 1 less than 1. And this is implies x plus 2 absolute value less than 4. And then we can also write x minus 1 equals x plus 3 minus 3 minus 1. Then we can write x plus 3 absolute value minus 4 is less than x minus 1, because triangle inequality, we can easily write this one. And this less than, let's say you pick some, like, let's say in here, you can, let's say from here, yeah, you just put it here, and then let's say you pick here, let's say x1, let's say you put 2 here for some reason, right? Just an example. And then you can write x plus 3 absolute value minus 4, it is less than x minus 1, and this is less than 4. And then you can put, sorry, it is 2. It is 2. And then you can write x plus 3 is absolute value is less than 6, and then you have 2 delta values. When you're writing your final proof, because these 2 equations will imply, we know x minus 1 minus 1, this is imply x plus 2, x plus 3, x minus 1, this is less than, x plus 2 is less than 4, so 4 times x plus 3, x minus 1. And then x minus 1 less than, let's say 2, this is implies 4 times x plus 3 times x minus 1, this is less than 24 times x minus 1. And then your final delta would be epsilon over 24. So when you're writing the answer, you can write simply delta equals minimum of 1 times 2 times epsilon over 24, and then you can write the answer. Usually we can have more epsilons as you need it, but what we'll have, but because when you have constant epsilon value, you can definitely pick the minimum of this one, because you can straight away say. But if you need to simplify your solving or to simplify your algebraic operations, you can always pick multiple epsilon values to avoid, let's say, avoid fractions or that kind of thing. And then you can, finally, you can write this statement like this. Even you can pick 10 deltas. Oh, it doesn't, I don't think you will get a question to use 20 deltas or 10 deltas. You at maximum you would use 3 deltas or 4 deltas. That's the maximum that you will go for at this level. But it is fine to use more than 1 delta to show that one, because in these problems too, we use more than 1 delta. But the problem is, whenever you are writing your final answer, it should be right using 1 delta. How you pick this 1 delta? Because after your rough work, you can pick the minimum of all the delta that you consider in your rough work. Then for that delta, all of this inequality will hold. Okay? Or is it need to explain it again, or is it clear? Is it clear that the question is asking? This one asking, is it okay to consider delta to imply inequality sometime? Okay. Yeah, this one. Oh yeah, we can still use just 1 delta value for 2 instances if it is easier, right? Yeah, you can still use. That's also fine as long as it is a positive value. Any value you pick to delta should be a positive value. You cannot pick negative values for delta. It should be a positive value. Basically, I strongly recommend that you're gonna look at. I will share you 2 videos on the limit definition. I think because the problem is I think the most question that you ask from even from the WhatsApp, I understood that you haven't got the idea correct of the limit definition, and you are thinking in a way that you can solve. I think the idea that you get you into mind the limit definition is quite, I would not say quite wrong, and I think I would say you haven't understand it properly. That's what the problem. Are y delta less than equal to 1 and epsilon 8 considered instead of equal to those? Thing is this, because when you have to consider multiple deltas, for example, if delta is if my delta is 1, if I take 0 is greater than 0 greater than x minus 2 absolute value and it is less than 1, if I put 1 here instead of delta, I can get this condition. But in order to save this one, I need to be x minus 2's absolute value less than epsilon over 8. So these are 2 different delta values. In order to hold these 2 inequalities for a 1 delta value, we need to pick 1 common delta to be that can satisfy both these 2 together. To do that one, we pick the minimum out of these 2, because when we pick the minimum out of these 2, if this x minus 2 absolute value is less than that minimum value, it's automatically less than 1. And if it is x minus 2's absolute value less than that minimum value, it's automatically less than this epsilon over 2 value. That's why I pick this minimum value, because in this rough work, we consider this value 1 separately and epsilon over 8 separately to get this, move forward from this inequality. But in our final thing, because for any given epsilon, we have to pick 1 delta that satisfies this one. Because here, delta equal 1 doesn't satisfy this equation. It's only satisfy this one. Okay, delta equals epsilon over 8 doesn't satisfy this. It's only satisfy this. We can only get this if our delta satisfy both of these together. To get that one, that's why we take the minimum one. Is it fine? Or is it clear? Yeah. Yeah, someone is asking to do one more question. Okay, so I will show one more question. Let's say limit, let's say x goes to, let's say, minus 1 is x squared plus, let's say, 2x plus 1. Okay. So this is limit equals 0. We can just put, because I just put the x plus 1 squared. And then if we need to prove this one, we need to prove all epsilon greater than 0, the x delta greater than 0, such that 0 greater than x minus 1 means x plus 1 less than delta, which implies x squared plus 2x plus 1 minus 0 less than epsilon. And it's quite easy because our this value is 0. Then we can put here, oh, it is, let's say put this is 2. Otherwise, this becomes trivial. I would say it is 1. Let's put someone else because otherwise it is become trivial. It is not much, because I just need to make some problem that can be easy to work, not easy to work with it, to show something. Let's say it is plus 3x plus 1, and then it is become x squared plus 1 minus 2, and it should become minus 1. Okay, this become x squared plus 3x plus 1 minus 1 is plus 1 less than epsilon. Then same as previously, we need to find some delta where this satisfied. It should imply that one. We can factorize this later, 3x plus 2. So this is become x plus 1, x plus 2. So here we have x plus 1 here, and we have this one, but this one we don't have. So we start with this one, and we write this in terms of x plus 2. How we can write that one? This x plus 2 minus 2 plus 1. Okay. So this I can write x plus 2 minus 1. Okay. Now, I can take, if I take 0 greater than x plus 1 greater than, because it is 1, and then I need to put something like, I would say half, right? I can still put 1 because I just need something, some positive number to tell that it is less than that positive number. For this type of thing, it should be still fine, but to avoid confusion, I just use some positive number less than 1, absolute value of minus 1. Okay. So then here, I can get, from here, I can just put x plus 2 absolute value using triangle inequality less than or equal x plus 1 absolute value less than or equal half or less than half, right? So then I can put x plus 2 absolute value less than, you can move minus 1 to other side, it is 3 over 2. Then I can say 0 less than x plus 1 less than half. This is implies x plus 1 times x plus 2. This is less than 3 over 2 x plus 1. This is my rougher. And then I know from here, if I put my delta to be 2 epsilon over 3, and this will imply x plus 1, 3 over 2 less than epsilon, and this is game done. So I put my delta equals minimum of half and 2 epsilon over 3. Then I can put 0 times x plus 1 less than delta less than or equal half. This is implies x squared plus 3x plus 1 plus 1 less than epsilon. So not epsilon, it is less than 3 over 2 x plus 1. And then also I can put x plus 1 less than delta less than or equal to epsilon over 3. This implies x squared plus 3x plus 1 plus 1 less than, oh, I don't write this one. I can write simply 3 over 2 x plus 1 less than epsilon. Then I can say, therefore, 0 x plus 1 less than delta. This is implies x squared plus 3x plus 1 plus 1 less than epsilon, because this less than this implies, and also if we take both of these two together, because I can simply put here it is epsilon, because although there are we taken using two different deltas, but once we take this minimum value, for this minimum delta value, this one holds, it means this should hold. So then simply, then after that one, you can just write the definition and say, okay, limit is this one for this question. It is clear, or yeah, I will do a function with fractions. Is it clear, or do I need to explain it again? Okay, someone asked if we need to do with the division. Okay, I will do. Okay, so let's take on the question. I notice I'm going to go too fast because I just need to show you how to solve this one. And let's say limit x plus 1, and I would say, to make it simple, let's say x plus 1 divided by x plus 2. This equal, actually we know 2 over 3, right? Now, this is thinking interesting. Just have a look how we're going to do that one. So if we need to prove this limit, we need to prove for all epsilon greater than 0, the x is delta greater than 0, such that 0 greater than x minus 1 absolute value less than delta, which is implies x plus 1 divided by x plus 2 minus 3 over 2 less than epsilon. Okay, so once again, same procedure. We need to pick some delta, which implies this one. X plus 1 minus 3 times, so 2 times x plus 2 divided by 3 times x plus 2 less than epsilon, and then we have to prove this becomes minus x minus x minus 4 means oh sorry, I have to forget to multiply this one, right? Pretty old. 3 times x plus 1. Okay, so 3x minus 2x means x, and plus 3 minus 4 means minus 1, divided by 3 times x plus 2 absolute value less than epsilon. Then this is, we have to show in simply 1 over third x minus times x plus 2 absolute value less than epsilon. Now, in the numerator, we are totally happy because x minus 1 over there, we can get x minus 1 over there. But in the denominator, we have x plus 2. So we need to get rid of that one, right? Basically, we have this one. If I write it separately, at the top, we have this one, and at the, so it is x minus 1. And in the denominator, we have x plus 2. And we have additional 1 over 3, and we have to, it is less than epsilon. From this term, this one, we are very happy because it's the same thing as this. This one is also, we are happy because it is a constant, right? Because if you put delta to be, let's say 3 epsilon, then straight away we can say this part is less than any positive integer. But for this part, we can't. This guy
We can't, right? To handle that part, we need to get some positive constant m in such a way that it is greater than or equal 1 over x plus 2. If we can have such a constant, we can tell 1 over 3 x minus 1 absolute value plus x plus 2's absolute value is greater than or equal m over 3 x minus 1 absolute value. And once we take our delta to be 3 epsilon over m, we can tell this whole thing is less than epsilon. We'll automatically tell this guy is less than epsilon. Because we need to get somewhat larger than this, and we tell, okay, if this is less than epsilon, it doesn't matter because this is anyway smaller than this one, it is less than epsilon 2. But to that one, we need to get some sort of inequality to tell this one is less than epsilon. In other words, we have to some positive constant in a way that said x plus 2's absolute value is less than or equal 1 over m. So in other words, we have to tell some positive constant a 1 over m is less than or equal x plus 2's absolute value, right? So we need to find some positive value which is less than this x plus 2 value because it is in the denominator, right? Because if we need to find some positive value larger than that one, if we switch this denominator and numerator, we need to find some positive constant 1 over m where it is less than the absolute value of x plus 2. Okay, to begin with, we will write because we have to, this is the only thing that we can work with. So we will write this way, x plus 2 minus 2 minus 1. So this is become x plus 2 minus 3. So put any value, right? Put any value to your delta which is less than, as I mentioned, less than absolute value of 3, right? So 1. So absolute value of 3 is 3, so I can put 1 here. And then this is implies. And yeah. Now tell, when I take the triangle inequality of this one, I can take two equations. One is x plus 2's modulus minus 3 is less than x plus 2 minus 3. This is one thing. Other thing is 3 minus is not 13. X plus 2's absolute value is less than this guy. Now you tell, what should I pick for this problem? This one or this one? I need to get something smaller than this one, right? So what I need to pick, this one or this one? How do you gonna pick? If you need to pick some positive value greater than this one, pick this. If you need to pick a positive value less than this one, you need to go with this expansion. When you go with expansion, then you can tell 3 minus, I will put here, I take the another sort of equation because 3 minus absolute value of x plus 2 is less than 1. And then I can put x plus 2's absolute value is greater than 2. And then I can put, from here, I can say, this is implies 1 over x plus 2 absolute value is smaller than half. Remember, if we put, let's say if you put 5 over there, what would happen? If you put 5 over there, what would happen? This 2 become minus 2. So that's why I mentioned the thing that you put here, because when you put 1 to this side, it will become 3 minus 1. If you need to end up with a positive constant, this should be less than, this is absolute value. That's why I tell you at the beginning. So then you can handle both ways of equations without worrying what number to pick. Then you can substitute that one, and then this is implies 1 over 3 times x minus 1 divided by x plus 2. This is less than 1 over 6 times x minus 1, right? This is very easy. Now, all we have to put is delta equals 6 epsilon and we are done, right? So we would write delta equals minimum of, I would say 1 and 6 epsilon. Because my second delta is 6 epsilon. According to here, because it is 1 6 times x minus 1. So if I put delta y equals 6 epsilon, this straight away become less than epsilon. So then I can write 0 times greater than, okay, delta greater than or equal 1. This is implies this one is nothing but this one. Two over 3 less than 1 over 6 times x minus 1. Because this is nothing but solved version of this one. I just read the original form to increase the clarity. And 0 less than x minus 1 less than delta less than or equal 6 epsilon. This is implies 1/6 of x minus 1 is less than epsilon. And then we can tell less than delta. This is implies x plus 1 divided by x minus 1, so x plus 2 divided by 2 over 3. This is less than epsilon. So then you can write, so therefore, for all epsilon 0, blah, 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 and less than epsilon, therefore, limit, you can write your answer. But the thing is, if you have a denominator, remember that you have to go with this expansion, not this. So in order to avoid confusion, it's always to pick a real number less than absolute value of this to be your delta, then you can use both equations. Okay? So someone is saying, Aya, what if numerator and denominator has same x plus a where limit is a? You can please describe a couple of examples. Then let's say if you have something like, you're asking, correct me if I'm wrong, you're asking like you have, let's say, x plus 1 and you have x plus a, and then let's say x plus 2 and let's say some kind of x plus a. Then you can just cancel out, right? So if numerator and denominator has both same x plus a as the factor, you can just cancel out. Because that's fine. You can just canceling out. Because then you can because the thing is like when you are considering the limit, something like this, let's say it is y or something, you consider some arbitrary small neighborhood around y. So then you consider arbitrary small neighborhood around y, you can escape the situations where x equals minus a or any kind of I would say the zero factor, so the roots of that equation. So then you cannot encounter 0 divided by 0. In limits, you can just cancel out without worrying about the 0 divided by 0. So you get basically you get the simplest form and then you prove for that one. Any questions? Or you basically you can unmute your mics and ask the questions rather than type in the chat, so then it is way much easier. And someone is, if you get 1 instead of half, is it incorrect? No, it is correct. In the last question, I think you are asking from here. Where I think I put half here is something over here, right? Yeah, you can put 1 here too, right? That's fine because you need to get something greater than this one. So then that's fine because this one is going to this side as a plus positive value. But here, if you need to get something lesser than this one, it is mandatory to put something less than this absolute value. To avoid confusion, that's why I say to be on the safe side, always take that dimension term less than the absolute value of that constant term without x, right? So it is much easier. So then you don't have to think. As you practice, you always do. Otherwise, you have to go back and forth, and it is can bit of confusing. But if you get more practice, then you can straight away you can decide where we have to put 1 and or where to put take the simplest form. But if you are already confusing with definitions, so it is better to
practice to some one way, and then you can solve the problems. And with pretty much ease, then you get more practice, then you can do in a much intuitive way. But to begin with, it is better to use in that way. Yeah, so any questions? Okay. So yeah, is it the case? So then I will explain how the rational numbers become a countable set using some example, and how we're going to prove that. And it is not a proof, actually, it is kind of a description, or I would say intuition description, or in we learn it too, and also it is in the YouTube too. So let's say your rational numbers, I just write it this way. So then if you have any question, you can put it in the chat while I'm explaining. Let's say you write numbers in this way. I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, kind of thing. And then you can write 1 over 2, 2 over 2, 3 over 2, 4 over 2, 5 over 2 in this way. And then you can write 1 over 3, 2 over 3, 3 over 3, 4 over 3 in this way. And you can write 1 over 4, 2 over 4, 3 over 4, 4 over 4, 5 over 4 in this way. Right? If you write your numbers in this way, you will start from here. You will go in like a spiral way. You go to here and here to here. Then again you go to, what is it? You go to here and you go to here. And then you go to here and you go to here. And you go to here and then you go to here. And you go to here, go to here. And you can draw kind of like this spiral thing, right? Throughout your grid, number grid. And then you can start numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and kind of thing. So then it's true that rational numbers can duplicate along the way. For example, 1 is here, 1 is here. Along the diagonal, you can have 1s. But the thing is, it means like rational numbers can get multiple numbers, but the point is you can cover entire rational numbers and assign at least one natural numbers to it. And that is in case the definition of the countable sets. So this is actually the proof for the intuition explanation, how you can treat rational numbers as a countable set. So then you can, alternatively, you can just draw this trick and say, okay, if you go in this way, then you can assign a rational number to any given rational number, a natural number to any given rational number using this method. You cannot left out, you won't left out any rational number, and you can get it to rational number. And someone asked, how you prove a limit of a constant is the constant itself? Go with the definition, right? So let's say your fx is a constant function, right? Fx is a constant function. Then write the limit definition. For all epsilon greater than 0, there exists delta greater than 0 such that 0 less than x minus, let's say, limit x goes to a fx equals c. You need to prove that one, x minus a less than delta, which is implies fx minus c less than epsilon. So we know function is a constant, so this is simply becomes c, and this simply becomes 0. So absolute value of 0 is 0 for any x value. This absolute value is 0. So we know epsilon for any given positive number, 0 is less than that positive number. So this part automatically hold irrespective of this delta. So any delta works. So it's nothing to prove there. You just write the definition and you just have to tell this part fx minus c minus epsilon, because this becomes 0 since fx is a constant, is hold irrespective of your delta. So that's the proof. Actually, you have nothing to prove. I just have to mention that one. I just sent image of your tutor. Can you please do highlighted? Okay. I think. Oh, what the hell is that? Okay.
So this is a very difficult one, to be honest. Okay. So basically, what we have to do is here. Yeah, first we need to find some roof there. Let's say 8, 13. Yeah, so somebody has sent me this question. Limit x goes to -1, x to the power 4 minus 3x squared plus 2 divided by x cubed times 5x squared plus 3x minus 1. This is equals minus half. This is the thing that you need to prove. So eventually you need to prove for all epsilon greater than 0, the x delta greater than 0, such that 0 greater than, let's say, x plus 1 less than delta. This is implies this whole bunch of things, x3 plus 5x squared plus 3x minus 1 plus half less than epsilon. So what you have to do is, actually I'm not going to do it here, I just put the s. First, simplify this one. First step is simplify this one. This one. And number 2, factorize. Both numerator and denominator. If we do it correct, I'm pretty sure in the numerator, there must be a factor of x plus 1 for the numerator. Numerator is something like this. The denominator is something like this. And then, after you factorize this one, you have to take inequality for each of these items, starting from something like x plus 1, some delta value here, and you have to get inequalities for the items in the numerator. You can find some positive constant which is greater than those values. And the items in the numerator, so the denominator, you have to find the positive numbers which is less than those factors. So then once you find those ones, then you will end up with, until you find with some positive constant times x plus 1, and then you have to get your final data to be epsilon over m, and then you done it. But for the fact, actually this part, the difficult part is to factorize this one, and then based on the simplest form of factors, you have to derive the inequalities for that one. So that's the approach that you have to take on. It is kind of cumbersome, I know, but I think if you factor out this one, you can easily solve your equation. Anything? If you don't have time,
Yeah, I will try to send it this one. Someone had put into the chat like the factors are this one. Yeah, I know, because I'm not going to solve this one here because it will be much cumbersome, and with this space I can do. What I do is, like, in later time I will just do it and pass it to you. Most probably, I think you can get away with the factors in the numerator pretty much, because you have some sort of polynomial, so some algebraic stuff, and yeah, let's see how we can do. I think I will try to explain much of the details include there. So as a finishing note, I have to tell you that don't I would say be fear to these ones. How to solve factors don't work, and it has complex root. Then you have to use the knowledge of your algebra. So you have to think of way that how to simplify these things, because the thing is, you don't need to factorize this exactly, right? In the last term, let's say you have something like this. Let's say you end up something like this. Let's say x plus 1 times, let's say, x plus 2. It is some hypothetical situation, and then you end up with x squared plus 1. And then simply you can tell
this is less than this, because this x squared term, we know for pretty sure it is greater than or equal to 0 because it is a square. So then you can straight away tell this denominator is greater than 1 all the time. So we can just put denominator 1 here without putting the x square. So then this is become greater than. So you have to use this kind of tricks to simplify that one, because you need to solve this exactly. What you have to do is get something simpler but larger than that one using some algebraic operations, and then try to prove that is less than epsilon. You don't have to prove this exact thing less than epsilon. You can just simplify removing some terms and get something larger than this one. And you can tell, okay, this thing is less than epsilon, so this should be less than epsilon. That is the way to go.
Is it clear? I think if you are asking the complex root question. Yeah. So anyway, like I will send you this answer for that question, because it is, because in a while I'm not did some that level of question, but I think it is a good exercise for me as well to my day. I will just send it to you after doing. It's a question that you can ask, but my major thing is, but because I know it is kind of quite fast for you guys, because I solved several problems. Just rewatch this recording, and I will send this notebook to you. I know my handwriting is not bad, but you can refer them. The thing is, you have to get the pattern of it. It's not a big thing. The only, I think, the difficulty for you being there are some sort of Greek symbols out of there, and there's a kind of new way of solving problems. But see, once you get the pattern, it's become very easy. Do not fear to these ones, because if you fear to these one, you will be struggling next semester's mathematics modules, specifically multivariate calculus and the, I would say the all of the maths module, linear algebra and everything. Because linear algebra is kind of different, but for the calculus modules, I think you need these kind of things. The definition of the limit, definition of derivative, and definition of the sequence and series. And I think also in your curriculum, you have, these are things that you have. I just write it down. I'm not sure whether all are included to you, but in our days, we have limits, we have differentiation, and we have sequences, and we had series. Believe me or not, if we can do this correct, limit is the fundamental of definition, and sequence and series, the same definition applies. If you can do this properly, you can easily do these two or these three things. But if you if you weren't able to do this thing, or if you not much pay effort to understand truly what is the limit definition, suggest how you prove the things using the limit definition, you will struggle in these three too. Because these three things built upon the same concepts. There's no escape. If you take the convergence definition of the sequences, it is kind of this thing. Infinity an L. So it is another limit, right? So differentiation, it's another, differentiation is defined by a limit also. Series is again a limit. So there's no excuse, especially in the first semester. If you haven't understand the limits properly, then you won't understand other three things properly as well. So make your effort much on the limits. I guarantee if you understand this thing properly and how to write the definition for a limit, not only for this simple case, I go to the beginning, not in the simple case, sometimes this way, right? What will happen this if this A becomes infinity, or this L becomes infinity? And what will happen with if this limit is left-handed? What will happen if the limit is right-handed? And those kind of things you have to focus on. And if you can really understand what does this limit definition mean, if you understand the pattern, you don't have to memorize, I would say, 10 to 15 versions of this limit definition. You can just understand the idea, then you can write definition for any of the different versions of it. But it will take some effort. So make your effort, commit a little bit. Once you understand that one, it will make a piece of cake for you. That's guaranteed. But you have to make an effort. But if you not make an effort, that's going to be a problem. Okay. Anything to be discussed other than that one? Okay, so I have a call after this one. So another meeting. So then I'm gonna end this meeting for now. For sorry for that one. So if you have any problem, just send it to me, and I will share the recording with you all. And if you have any problem, you can just chat in the WhatsApp group as well. I think I added yesterday the one of the bus stopper from the 22nd batch. So then he's more than happy to help you guys in the differential equations as well as in the programming. And also there are going to be more 22 people going to be added to your group as well. So make sure that you get all help from that one, and make sure that you're going to continue that trend for your future batches as well. So that's it that I'm gonna tell you. And if you have any questions, you can just WhatsApp me or put into the group. And it is better if it is a subject related matter, it is put it into the groups, because then everyone knows that one. So then if somebody in your batch knows, so then I can wait a little bit and see whether you can just answer or not. Then because it is so good for you guys as well. It is kind of a make it a peer discussion, not a kind of a teacher or kind of thing. Just make a peer discussion. Yeah. So I think hope this helps. And okay. So meet you in the next next week. If you have anything to specifically discuss, just send it through, so then I can just have that one. Okay, goodbye.